Welcome back, guys. Today's video is going to be covering the photoelectric effect. So the photoelectric effect describes a process where if you have a metal, right, and we know that metals are made up of electrons, right? If you have this metal and you hit this metal with a light wave, and we know that light waves have a wavelength, a frequency, and an associated energy value with them, right? So that energy value is going to be important because this light wave carrying energy can hit this electron, give it enough energy to actually eject it or send it on its way from this metal carrying kinetic energy, right? So the photoelectric effect describes this interesting process, right, where we have this light wave carrying energy. It gives the energy to this electron and it actually sends it away from the metal with a certain amount of kinetic energy. Now, we need to break down the photoelectric effect a little further. And one of the most important concepts that we need to go over is the concept of threshold frequency. So the threshold frequency is going to describe the metal, right? So the minimum frequency a wave must have to ionize an electron from a metal. That's the definition of threshold frequency. So if we have a metal, right, what this threshold frequency is saying is that if you shine a light wave on this particular metal with a particular threshold frequency, different metals have different threshold frequencies, right? If you shine a light wave on this particular metal, this light wave must have a minimum frequency to actually give this electron enough energy to be ejected. So let's actually do this with some numbers. So let's say the threshold frequency for this particular metal is 3 times 10 to the 15th, right? That's going to be our sample threshold frequency, right? So that means if you want to eject this electron from this metal, the minimum frequency that this light wave must have, if you want to do that, is 3 times 10 to the 15th. So anything less than that, you are not going to be able to eject that electron. It's an all or nothing type of deal. Unless you meet this value, you are not going to eject that electron. Now, let's imagine that this light wave has a frequency of 4 times 10 to the 15th. So, will this light wave have the proper frequency to be able to eject this electron? Yes, it will, because the frequency, the threshold frequency, I should say, of this particular metal is 3 times 10 to the 15th, and this is 4 times 10 to the 15th. So, what happens now that we have a frequency that is able to eject this electron? Well, I like to think of it in terms of energy, right? Because in reality, this light wave is carrying an energy value that gives this electron enough energy to leave this metal. So remember our important equation. The energy of a wave is equal to Planck's constant, which is 6.626 times 10 to the negative 34th, times the frequency. Our frequency here is 4 times 10 to the 15th. Now, what we're saying here is that this light wave is going to have an energy value associated with it. If you were to plug in these numbers, right, and multiply them out, you would get an energy value, right? Now, this light wave is carrying that energy value. Now, similarly, if we have this threshold frequency, we can actually think of it in terms of energy. So again, we did E equals H times our frequency, right? And we plugged in our 3 times 10 to the 15th. We would also see that not only do we have a threshold frequency, but we can think about it in terms of like a threshold energy, right? So our light wave, it has a frequency, it has a subsequent energy value, right, that it needs to meet. Now we also have this threshold frequency of the metal that this light wave needs to meet, but we can also think of that in terms of a threshold energy, right? It needs to have a certain energy met in order to, eject this electron off of the metal. So what we would see is that because this number is larger, right, this is going to be a bigger energy value than this energy value, which has a smaller frequency. So when you have this bigger energy value, it's going to go in to first meeting this frequency, this threshold frequency or threshold energy. Then any excess energy left over is going to go into kinetic energy as the electron leaves this metal. Now, the analogy I like to make here is imagine that there is an event or some sort of place that you're going to that costs $10 to get into that place. Now, once you get into the place, there are tons of other things that you can spend money on, right? So imagine you get to the front desk of the place and they say that it's $10 to get in. That is synonymous with this threshold frequency, right? The first $10 needs to go into meeting the threshold, right? So if we have this energy value that we see with this light wave, when we plug H and 4 times 10 to the 15th in, we're going to get an energy value. That energy is going to be first used up for meeting the threshold, right? So you can't take $20 and go to this event and instantly start spending it on whatever you want. The first 10 has to go to the person at the front to let you in. So that total amount of energy is going to be used up first just for meeting the threshold. Now, once you've successfully given your $10 or you've met your threshold, that means that your remaining energy or your remaining $10 can be used to spend on whatever you want or as kinetic energy. So that's the analogy I like to make there. So I like to connect frequency with energy to remember that even though we're dealing with a threshold frequency, we are still talking about energy values, right? And that energy is first going to go into meeting that threshold, and then any excess is for kinetic. So if we go to tackle a practice problem, it says a wave with a frequency of 7.5 times 10 to the 15th hits a metal with a threshold frequency of 5 times 10 to the 15th. Will this light wave ionize the electron? So let's do this out. So now our metal has a threshold frequency of 5 times 10 to the 15th. Okay? Our light wave is 7.5 times 10 to the 15th. So, will this light wave ionize the electron? Now, ionizing the electron means you have enough energy to eject it from the metal. Well, in this case, yes, our threshold is 5 times 10 to the 15th, and our light wave has a frequency of 7.5 times 10 to the 15th. So yes, we have met the threshold. We are actually above the threshold, right? So yes, we are going to ionize this electron. It says, how much excess energy will this electron have as kinetic energy, right? Ke is kinetic energy. So we clearly have more frequency than we need to, ionize this electron and send it on its way. So what I like to do is say, okay, I have this frequency. Let's convert that to energy. So if we do E equals our H, which is 6.626 times 10 to the negative 34, that's our Planck's constant, right? Times our frequency, which is 7.5 times 10 to the 15th. If we plug this in, we get a value of 5 times 10 to the negative 18 joules, roughly. Okay, so this light wave is carrying 5 times 10 to the negative 18 joules. Now, if you don't know how I did this, make sure to check out my channel. I go over how to calculate the energy of a wave using Planck's constant in the frequency. Okay, so how much energy do we need to use up just to meet the frequency, right? Just to meet the threshold, right? The $10 that we need to give to the person at the front before we go in. So this is how much energy we have. This is the frequency we need to meet, but let's get the energy. So E equals H times this frequency, right? And if we calculate that out, the energy here is 3.3 times 10 to the negative 18 joules. Okay? So we've met our threshold frequency, but I like to turn it into energy so I can see what I'm working with, right? So 5 times 10 to the negative 18 joules, that's how much this light wave is carrying. This metal happens to have a threshold frequency of this, which really means we need to give this metal that much energy in order to eject an electron. So yes, we're going to eject it. And how much excess energy are we going to have left over, I should say? Well, this minus this will give us So 5 minus 3.3, they're both times 10 to the negative 18. That is going to be 1.7 times 10 to the negative 18 joules. This extra energy is going to be used as kinetic energy to send that electron away from the metal. So it's important that you know how to work through a photoelectric effect problem and you understand threshold frequency and everything I went over in this video. Thank you for watching and make sure to check out the rest of the videos on my channel.